like the magnitude, when I'm thinking about it algebraically, it's very simple to do magnitudes now. Another thing that becomes a lot easier is the addition of vectors. So our old way of doing it is we would just simply graph these. So if I was doing u, I would go over 2 and up 3, and it would end there, and my vector would be right here. And then if I was to graph the other one, I would go 3 to the right and down 2, so it would be there. And then that would be my other vector. And then if I was just going to add them, I would have to create this parallelogram, and that would be, here it is. So now from here, what would I generally do? I would say, okay, let me draw my vector now. And that vector would be my a plus b. And if I was to write that vector, it would be, and then I can see that it goes over 1, 2, 3, 4, 5, and then it goes up 1. So if I was to write this vector, u plus v, I would say that it equals 5, 1. And that's what it would be. Now take a look at this. This is so much nicer way to look at this. So now if I just think about these things algebraically, or not algebraic, yeah, algebraically, I'm really going to have my u being 2, 3, plus my v being 3, -2. And then if I add these, it's just going to be a component-wise addition, so I'm going to add these two here, and then those two there, and that's going to be 5, and then 3 plus a -2 is going to be 1. So again, it just saves so much time, and it's very simple if I can write these vectors algebraically and then just add them component-wise. It's so much nicer. And subtraction is also very nice. So if I had to find u minus v, okay, which we could do, that's just going to be u is 2, 3, or bracket, minus 3, -2. And then all I would have to do with these is just subtract them instead. So 2 minus 3 is -1. And then 3 minus a -2 is 5. And then if I just think about this algebraically, if I'm doing a subtraction of the v instead, that would simply mean, and I just kind of want to show this to you algebraically, that means I would be going up 2 and over 3 here, because I got to negate my v. So that would be this line. And then if I created my parallelogram over there, then it would be this way as well. So that means this one here would be going up 3 and over 2, so that would be here. And then this one would be here. And then if I drew the vectors between those, I would get this one right here. So I'm just going to draw it in another color so it's kind of easier to see our answer for this one. So it'd simply be that one. And then that one would be -1.5 if you take a look at the answer we got. So honestly, it's so much nicer if we're just able to do them algebraically. But you can see how that works both ways.